Hey everyone, welcome back. Today I'm going to show you how to update your Python projects remotely over the air using a GSM module and a cellular data. Whether you're running a Raspberry Pi out in the field or managing remote IoT devices, this method can save you a ton of travel time and hassle. The best part of this, it's secure, lightweight, and all you need is a Python on a Raspberry Pi, which is your project, a basic web server, and a GSM connection. So, here how it works. Your Python script runs on a remote Raspberry Pi. At the startup, the first thing the script is doing is to check um, online or on your server if there is an updated version of the code. If no, then it's gonna proceed with the current code that is already running. If it say, okay, I can see that the new version has been released on the server, it's 1.0.1, then it's gonna start downloading the the new version of the code, is gonna install it or rewrite the current one, and at the next startup it's gonna load the new one. You can choose whatever you want to run the check at the startup of the code, or if you want it uh, to check for an update at the startup of the Raspberry Pi. But because our Raspberry Pi is going to run 24/7, as soon as we release the code, um, we're gonna put an interval or something. So, for example, every couple of hours to check if the new code, if there is something new on the internet, then download it and run it on the Raspberry Pi. We are going to keep everything lightweight, so it works even if with a spotty 3G or 4G networks. So let's start with the server side. You only need just two files hosted. The first one is gonna be the latest version .txt with a update with a version on it inside, and on the second file, latest script.txt again, is going to be the main code of your script. Let's keep it simple for this step. Just put a hello world test inside. Um, on the server side, that's it. I'm using my own web hosting, but this can be any basic HTTP server. So, on the Raspberry Pi side now, we're gonna include a script called autoupdater.py, which is going to be handling the update logic. It compares the remote version with the local one and updates if it needed. So, as you can see on the Raspberry Pi, we have the main script and the updater and the autoupdater.py file. On the main script is the same one as the one we have on our server at the moment. Autoupdater here is when the magic happens. We have the version file, which is gonna come and search on this one online on our server, and the latest script .txt as we said before on our server, and the target script it just is to save the latest script.txt into the main script.py um, on our Raspberry Pi. So if the remote version is higher, it downloads the latest script.txt and save it as the main script.py as we had before, then restart itself using the os.xcv function. That means you only run the update there once and your Pi take care of the rest. So let's test it. As you can see, instead of having a Raspberry Pi at the moment, I'm running Raspberry OS on a VM. It's completely isolated. As you can see, there is no network the adapter connected to this one. We do not have internet at all. And we come to run the project, we're gonna get an error that is failed to fetch remote version. It cannot go into the internet. It's gonna give us just the main code. So let's now connect the Raspberry Pi or our OS into the internet using this.
Okay, for secular communication on the Raspberry Pi or at this moment on the VM, I'm gonna be using this one. I bought it from Amazon, eBay, AliExpress, I don't remember, about 10 euros. Um, you just add the SIM card at the back, and once you plug it on the computer, it gives you the ability to connect through it on the internet, as well as give other devices access points. So you can connect to this one. You can connect up to 4 devices at the same time. 5 with a device that is connected with a USB, and you are able to browse the internet.
Okay, let's give the USB Wi-Fi GSM module dongle some time to connect to a cellular tower. And as soon as we have indication with the lights that are connected, I'm gonna pass the adapter on the VM of the like this. I'm gonna have the Android version, and as you can see, we are indeed connected to the internet or trying to connect using cellular data. Let's run the project again. So as you can see, we are getting that the local version is 1.0.1 and the remote version as well the same 1.0.1. So there is no need for updates. Okay, so let's make some changes in our on our server. We're gonna put that the new version is 1.0.2. Let's come here. I'm gonna update this one as well. And then hello world, this is v3 for YouTube and a smiley face. Let's run it again and see what's happening. Up, it found an update. So the local version is 1.0.1 and the remote version is 1.0.2. It's gonna download the new version from our server. No, came out of boundaries. It say that the update has been completed. It's restarting the script. by itself, as we said before, and now the local version is at 1.0.2 and the remote version is 1.0.2. So we are all up to date, no update needed, and hello updated world. This is V3 for YouTube. Hello updated world. Okay, my bad. So as I'm running the project in the Genie, I'm gonna say to reload the project, and here we have the updated version. So another thing that I have implemented into the code is when you download the new version and you're gonna switch to the new one, we want to keep like a backup of the old code. So in order, if something happened to the, for example, if we made mistake um, on the production version of the code, we're gonna be able to roll back to the previous version until we fix the version again. So with this, we're gonna keep a .pak file in our repository, and this is going to be our previous one. So we have something to go back. In the future, I'm also planning to add authentication headers in case to get it more securely. Validate give it the ability to validate the downloaded files before replacing anything. So in case that if I make a mistake and publish it on the server, the Raspberry Pi is not gonna come and download it. It's gonna first check it and then install it. So another thing that I'm working on at the moment is to create on my server an application that is going to get the reports from the Raspberry Pi. For example, if I have two or more Raspberry Pi um, remotely, I'm gonna be able to monitor with their feedback if they receive the update, if they have installed it, if it failed, and if yes, why. I'm gonna be able to push a separate update on each one. For example, if I get an error uh, on the Raspberry Pi C, I'm gonna be able to push it directly to that one only using an ID that I'm gonna set up on each Raspberry Pi separately. Each one is gonna have its own. I'm gonna be able to get some reports throughout the Raspberry Pi from each one individual. And it's gonna be interesting to see what you think about this one. Um, for this one, that's it. You now have a fully functional OTA update system for your Raspberry Pi projects using Python and GSM. It's perfect for remote deployments. And if you found this useful, drop a like, share it with a fellow dev, and don't forget to subscribe for more practical Python and IoT tutorials. Code and documentation links are in the description. Thank you very much. Have a nice day.